Hello again, folks. We are on our notes and homework, Unit 5, pages 1 through 13. In this video, we're going to be looking at pages, essentially pages 5 and 6 and 7. How do these atoms form an ionic compound? So I'm going to be focusing on the examples that are on page 7 for us to try right now. So how do these atoms form an ionic compound? So it might be easier for you to first think about whether what charges these ones are going to get. So let's do this first. We have Li plus N. And remember, Li, we can use our periodic table to tell us that Li has one valence electron. It's going to get a +1 charge. Li wants to get a +1 charge. N wants to get, where is N? Here's N. It's in our 5A column. It wants 1, 2, 3 more electrons to be totally full. So N is going to have a -3 charge. Once we put these things together, it's going to form, I want to make this into a much larger font too. Make it big. What's going to happen here is that to balance this out, we need more LIs. We need 3 LIs to balance out every one N. So our final formula is going to be Li3 N1. We don't have to put the N. Remember to make that 3 little by using the format, text, subscript, or superscript. Okay? Superscript makes it little on the top, subscript makes it little on the bottom. So when we're drawing how these are going to form an ionic compound, it means that we're going to need 3 LIs and 1 N. Knowing how many you're going to need at the beginning might help you. So what I'm going to do is just insert a drawing to show you how to make these. So we're going to need 3 LIs. So I'm going to make a text box that has LI and LI and LI, and I make these bigger. I'm going to make my font 25 so we can really see these. And I'm also going to include 1 N. 1 N. Now what I'm going to do is show those dots. So I'm going to draw in a shape. I'm going to draw in little dots so we can see. So here's Li has 1 dot. You can sort of see that dot, right? I'm going to copy and paste that dot. How do I move it? This is harder than it looks. Okay, never mind. We're not going to draw it like this. I'm going to draw it with the other thing. Maybe. Oh, I can move it with an arrow key. Okay. Li and for that Li. And I can make all of these. We're going to give it fill. We're going to give it solid fill. Now we can see those dots. Okay, each Li has 1 dot. And now I'm going to copy, Control C, and paste 1, 2, 3, 4, 5. We're going to give nitrogen these other dots. 1, 2, 3, 4, 5 dots. So what's happening here is that we want each of these LIs to give up their 1 electron and give it to nitrogen. That's why we needed so many. So now we're going to draw an arrow. We're going to draw an arrow from here to here. Oh, we don't want an arrow connector. Never mind. We're going to delete that one. We want an arrow from here to here. Can I move the arrow? No, I can't move the arrow. One arrow there, one arrow to that side, and one arrow from here to that side. Get rid of this other little arrow. So I know this is confusing. We've got this electron moving here, this electron moving to that side, and this electron moving to that side. So when we close, see how we've got each of those Li's had one valence electron to begin. The nitrogen had 5 valence electrons to begin because of where they are in the periodic table. Each lithium wants to lose that electron and have it go over to the nitrogen because nitrogen wants to get more electrons, right? Each of these wants to lose 1 electron, nitrogen wants to get 3 more. So we needed 3 Li's to draw all those arrows over there. Oh no, go away. Don't go away. Don't go away. All right, I'm just trying to make this a little bit neater. Nope, too far. Okay, so there's our picture. We've got Li, each that has a +1. We need 3 of those to make our formula Li3N. I'm going to do this with Mg and Br also. So we've got Mg plus Br makes Mg Br something. Let's figure out the charges. Mg is here, 2A, so that means it's going to have a +2 charge. And Br is here, which means that it's going to have 7 electrons. It wants 1 more, so it'll get a -1 charge. 1 charge. So that means that we need 2 Brs for every Mg. +2, we need -2 to balance that out. So MgBr2, remember, these become little numbers in the second part. So now, if we're drawing out our Mgs, we're drawing our Mgs, we're going to need 1 Mg, 2 Brs, 2 Brs. Our Mg, I'm going to do this a little bit differently. Our Mg has 2 dots, and each Br has 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So what that means is now we're going to want these Mgs. Each Mg is going to give up an electron. So Mg gives that one to that Br, and it gives that one to that Br. Because now Br had 7, now it has 8. That Br had 7, now it has 8. And that Mg got rid of its 2, so now it's happy and has that octet in the shell underneath. So this is what it would look like for that. Next, we've got, for the last one, Al and O. This is the complicated one because of the charges that they're going to have. Let me show you what I mean. Okay. So for Al plus O makes Al O something. Let's figure out the charges. Al is in the 3A column, so Al is going to have a +3 charge. Remember, make that little. Oops. +3 charge. And O is in the 6A column, 6 electrons. It needs 2 more, so each O is going to have a -2 charge. These don't balance out, right? We have 3 and 2. There's not an easy way to combine them. So remember, that 3 can just go in front of the O. 3 O's, and that 2 can go in front of the Al. Now the total charge we have is 2 times +3 for a +6, or 3 times -2 for a -6. +6 and -6 balance. You have to balance the charges. Now we need 2 Als on this side and 3 O's on this side. What do we got to do? Make them little. So format, text, subscript, format, text, subscript, All right, now we have our formula. So that means that when we're making our drawing, we know we're going to need 2 Als and 3 Os. So let's do that over here. We've got Al, 1 O. Al, and 1 O. There's our 2 Als, and now we need one more O. Let's make them bigger. Let's make them even bigger. Okay, so we've got our 2 Als and our 3 Os. Now let's draw on our valence electrons. Oxygen, Al here, Al needs 3 valence electrons. So let's draw on our 3. We've got 1, 2, 3. 1, 2, 3 valence electrons. Okay. Oxygen is here in the 6A, so it needs 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. How do we know which one wants to give and which one wants to receive? Al has a +3, so that means it wants to lose negative charges. O has a -2, so that means it wants to get more negative charges. Remember, those electrons are negatively charged. So Al is going to give 1 electron here and another electron there. But oxygen doesn't want any more because now it has 8, right? It had 6 and it got 2 more. That oxygen's fine. That's why we need the other oxygen. So now this Al is going to give that electron there. And now this Al doesn't have any more to give. So we go to the next Al. That Al is going to say, here you go, oxygen. You can have mine. So now oxygen had 6. Now it has 2 more. 1 from there and 1 from there. But Al says, I still have 2 I need to give up. That's why we needed a third oxygen. So that Al gives its electron there and its electron there. And now everybody's all set. Everybody has 8 at the end because it gave up those 3 to have 8 in the shell underneath. And oxygen got 2 more to go from 6 to 8. Here's our balanced charges. Here's our balanced formula at the end. Hope this helps. Good luck.